Hello, everybody. So one thing that we have not been putting into a lot of our presentations has been our objective, our MYP, statement of inquiry, etc. And I'm sorry about that. I do want you to read this on your own real quick, so you can see what we're doing today. And also, just kind of a little heads up, a lot of times after we start a whole unit on triangles, students are always wondering, why do we spend so much time on triangles? And in other parts of the country, Montgomery County doesn't do this, but triangles are such an important part of mathematics that you even have full-on classes that are year-long classes that deal with triangles, and the class is generally called trigonometry. Our trigonometry in Montgomery County is embedded into geometry, algebra 2, and pre-calculus. So you kind of get what everyone else gets, but triangles, and we're going to talk a little bit more about this, but triangles, even though you don't know it yet, are such an important tool that you're going to use to solve problems that have nothing to even do with triangles. So next two slides we're going to do together. You should have, I'll give you a second, hopefully you have your new packets. You don't have to bring in your old packets, but do not throw them out. We're in Unit 1, Topic 3. So Mr. Angor and I were kind of talking about whether there was even a need for SLTs or lessons 21 through 23. It's a pretty, I hate when teachers say easy, but it's a very straightforward concept that you have to learn. So we're just going to basically, instead of doing 19 pages, all which cover the same exact skill, we're just going to kind of talk about what you had to walk away with, which I don't think you needed to do an investigation to learn this. But in the past, we've been doing transformations. And transformations lead very much into this unit because, so if you have triangle ABC, and actually, I actually do not know. I don't have the pack in front of me, and I apologize for this. Maybe this is somewhere in your packet. I'm sorry to be so vague. It's got to be towards the beginning. I'm so sorry. The pages I have are the old pages. I think it should be on your schedule, but I think this is page I don't even know. I'm so sorry. So first person that can find this page gets $10 from Mrs. Street. Again, first person that finds this correct page gets 10 minutes from Mrs. Street. To be honest, you don't really even need to get to the page if you just kind of pay attention. All right, so basically ABC to XYZ. How would you go from here to here? Well, one of what transformation would you use? And hopefully you can kind of notice it's being rotated around point P. By the way, on some of your quizzes, you guys keep saying the origin. If it's a random point, it's not the origin. The only time it's the origin is if you're on an XY axis and you're rotating around this point. But just because it's a random point, it's not around the origin. Don't worry, I did not mark you wrong for it, but just in future cases. So when you do that, does the triangle change? And I don't mean does it go to a different position, and it does go to a position, but is this the same triangle? And if you, just by doing a rotation, if you remember when I spinned Harrison around on the ground, Harrison didn't change. Well, neither does the triangle. When you have a rigid motion, such as a rotation, reflection, or translation, the triangle doesn't change, and therefore it's congruent. You can get another congruent triangle by doing all these rigid transformations. That's kind of the first thing you had to learn from about 20 pages of work, that if you do a reflection, even though the triangle is facing a different direction, or rotation, or whatever, translation, the triangle doesn't change. And everything about this triangle and this triangle are going to be the same. Well, corresponding angles are just the angles that are in the new triangle that match up with the triangles here. So if you were to rotate this, angle A and angle X would be the corresponding angles. So you can say angle X is congruent. Oh, this is so annoying. Sorry, this touchscreen. Actually, I really should have said angle A is congruent to angle X. And the corresponding sides. So if A and X are the corresponding angles, And if you spin this, X and Z are the corresponding angles. The corresponding side would be this side and this side, meaning that that's like the same side. Those sides match up and they're going to be the same length, but that means the sides are the same, which would mean line AC. Notice you have to write the line above it because you're talking about congruence. Oops. Is congruent to line XZ. And then you would basically do this for all the angles and all the sides. There'd be 6 of them. There'd be 3 corresponding angles and 3 corresponding sides. And then you have a corresponding statement. And again, I like to write the first triangle in alphabetical order. And sometimes the second one won't. In this case, it actually will be in alphabetical order, but sometimes it won't be. But that's okay as long as you write the first one in alphabetical order. Remember, when you write a triangle congruence statement, and let me just write this real quick, X. Oh, isn't it? Oh, I don't think this does match up. Yeah, because it was be X, C, and Z match up. Oh, no, never mind, it does. My bad. X, Y, and Z. All right, now when you write a congruence statement, you have to be careful on how you write it. It's wrong unless angle A and angle X are the ones that match up. Angle B, which is second, matches up with angle Y, and angle C matches up with angle Z. How you write things is really, really important. So go ahead right now, and this should be on the very next page, or honestly, you can just look at it and just do this on a piece of paper. Go ahead and pause. And there's a little bit of a trick to this one, a little bit slightly harder. But go ahead and just write down all the corresponding angles and corresponding sides. Pause the video and then play it when everybody's done. So in this problem, the corresponding angles would have been angle A. Notice I'm not writing the measure of angle A because we're talking about angle A itself is congruent to angle C. Angle D is congruent to, so this is where some of you might have been like, I don't know what to do here, but angle D is actually congruent to angle D in the new one. And angle B is congruent to angle B. And that might seem strange to say, but there's an angle B in this triangle. If you separated the triangles, there would be an angle B over here. It's a terrible picture, and there'd be an angle B over here. There's actually 2 angle Bs, because angle B would be, there'd be a point angle B on this triangle, at triangle 1, and there'd be a point on angle 2. So you actually say angle B is congruent to angle B. Corresponding sides, you have AB is congruent to CB. Now, I want to make sure you pay attention to this. Note you could not write BC because angle A and angle C are the angles that match up. So as soon as I call one of the lines angle AB, I have to call the other one CB because angle C and angle A are the ones that match up. So it would be technically wrong, even though line BC is the same as CB, once you call the first one AB, you can't call the second one BC. You have to pay really close attention to what angles line up. And then one of the ones when you have AD is congruent to, and notice I have to say CD here because angle A and C are the ones that are congruent. So that's line AD and line CD. And the last one is this line. They share this line. Well, that line BD is actually, both triangles will have a line BD that'll be the same exact length, it'll be the same exact line. So you write BD is congruent to BD. It seems silly, but I mean, you're saying that they're technically, even though it's the same line, it's 2 different triangles have that line. Now, the congruent statement would be to say the triangle's congruent, you would have to say, so again, how you label the first one will change how you label the second one. So I'm going to call the first triangle in triangle 1 ABD. And I'm going to say is congruent. Now, you might have written this different. You might have said angle BDA, and you're not wrong, but I like to put it in alphabetical order. The second one would be triangle C, because angle A matches up with angle C, angle B matches up with angle B, and angle D matches up with angle D. Sorry for the sloppiness, but hopefully that makes sense. Again, the key thing to take away is that when you label things, even when you're labeling the triangles, the angles within the triangles have to match up. Oops, sorry. All right, so we're going to talk more about this tomorrow, but that line BD that they both shared, the fact that both triangles share the sign, I want you to write down this new vocabulary word. It's called the reflexive property, and it happens with both angles and sides. When you learn, we're going to talk again more about this, but you're going to learn these theorems, these properties, these postulates, these names of things. It's really, really important because you're going to start doing these things called proofs. It's really important. You actually have to memorize the names of them. You have to know, like when you see it, you have to be like, oh, that's the reflexive property. It's really important. We don't have to memorize everything, but like you don't have to memorize the exact dictionary definition. But you have to remember when two things share like a side or have the same angle. And I'm trying to give you an example of that. Like if this is angle, like if you call that angle C, there's a better example of this, but if they overlap angles, oh, I got you, hold on. Oh, you know what? I can't think of a good example of with the angles. I'll show you guys tomorrow. I'm sorry about that. But basically, if they overlap and it's the same side, so in that last example, it was the fact that both triangles shared this side. The fact that they're equal is obviously that they share them. It's the same one because it overlaps, but the property is called the reflexive property. Now I'm like really bummed out that I can't think of a good example with the angles. All right, now I want you to try one on your own. This is actually page 16 in your new packet, so Ms. Street doesn't have to give any more money. I want you to go ahead quickly and fill in the answer on page 16. Pause the video and you guys do it. All right, so here they're just talking about the beginning, the black one and the red one. But identify each rigid motion. So if you can see where D and E goes and F goes there, because you can draw a line through the rotation, this would be a 180-degree rotation around point or about point F or F prime. And then it is a reflection over the line XY. You're going to notice that even though this is a rigid transformation, the original and the end are congruent triangles. Identify the corresponding angles inside. So D and D prime are corresponding. We're going to write the congruent sign. We're going to write the angle sign. And then you don't write measure because we're not saying that they're equal. Even though congruent means that they are equal, you're just saying they're the same. E and E prime and F prime. And then you have line DE and D prime E prime, and you'd have to write it like that. So DE is congruent to D double prime and E prime. And I just realized I made a mistake on the, you're not talking about this one, you're talking about the end result. So all these should have double primes on them. Okay. And last, I want you to quick summary, 2 minutes on your own. And then I want you to check in with a partner. And then, well, this is normally where you'd ask me questions. Ms. Treat might be able to help, but I'll just go through it actually. But go ahead and on page 24, basically answer these questions. You're looking at the description and you're filling in where the points would be on the new figure. Okay, so go ahead and do all four on page 24, and then pause the video. And then before you leave, I want you to check in with a partner though, and then we'll just go over the answers. So if the first one is a reflection across BD, then A is going to go over here. I'm going to call it A prime, and C is going to go over here. And if it's a reflection across BD, then D and B are not going to move, but you still have to give them the prime signs. So now I have that. And the next thing is, it's the second rigid motion is a 90 degrees clockwise rotation around the center of the square. So if I take this, the new one, which is this one, and do a 90-degree clockwise, that means everything is going to go this way. So D prime is going to go here, C prime is going to go here, B prime, oh, it's actually double prime. Too many. And A double prime will go here. So this would be what your next one should say. DCAB, DCAB. I think I did that right. Nope, didn't do that right. Now it's right. Wait, A is in the left. Sorry, couldn't read whether that was an A or B. And the last thing is what would be the description of the last ridge of motion? So A and B and D and C are kind of flipping. So it looks to me there might be a couple different things you could say here. Nope, you couldn't really say because A and B are staying in the same position. They're just both flip-flopping. So this would be a reflection and over this line. Yep. A line, a horizontal line, I guess you could say the perpendicular bisector of AD or the perpendicular bisector of BC, a reflection over it. I'm trying to think just to make sure that there's no other way. Yeah, there would be no other way that that would happen. I guess you can say a translation where D and C goes up, where it's like this, and then a reflection, but really a reflection over the perpendicular bisector of line A, B, and BC. Right? I know it's a short period. Hopefully that filled the time. Make sure you check for the homework. I don't think I gave you guys homework because of you guys testing, but please make sure you check out the video just in case. I'll post it again. I'll keep posting these videos, and then I will tomorrow. You're gonna have hopefully a fun activity where you guys are gonna be manipulating these things called exploragons. So come in early, get ready, and we'll see you tomorrow.